In this lesson, we will discuss decoding interval inversions on the guitar using the NANDI method. An interval is a pitch distance between two notes. In an inversion, the bottom note moves up an octave, or the top note moves down an octave. Keep in mind that when an interval is inverted, the quality of the interval changes. Major becomes minor, and minor becomes major. Augmented intervals become diminished, and vice versa. Perfect intervals, however, remain perfect when inverted. The first inversion we will talk about is the inversion of the second and seventh intervals. Going up 2 frets from 1 to 2 is a major second interval, whereas going down 2 frets from 1 to flat 7 is a minor seventh interval. This implies that a minor seventh is an inversion of a major second. Another common shortcut is that the sum of the original and inverted intervals is always 9. In the second seventh inversion, 2 plus 7 equals 9. In the illustration below, C to D spanning 2 half steps or 2 frets is a major second interval. Remember, inverted intervals always total 12 half steps or 1 octave. With C an octave higher, we can identify D to C as a minor seventh interval spanning 10 frets. Remember, going up a major second is the same as going down a minor seventh. That is, going up 2 frets from 1 to 2 is equivalent to going down 10 frets from 1 to 2. While locating inversions on a single string is straightforward, locating versions across multiple strings can be tricky unless we use the NANDI method. Because there is a perfect fourth interval between 2 neighboring notes on the same fret, we must count in 5 half-step increments when traveling across strings. An exception here is the major third of 4 half-steps between adjacent notes on the G, B strings. Take a look at the interval chorder below. Fourths used as reference points are displayed as gray diamonds. Using 4 as our reference point, for example, we can locate a major second 3 frets below the root on an adjacent string. We can locate 1, a minor seventh away from 2, by counting 5 half steps from 2 to 5 and another 5 half steps from 5 to 1 for a total of 10 half steps. The next important inversion is that of the third and sixth intervals. A minor sixth is an inversion of a major third. You can see below that 3 is 4 half steps up from the root, and flat 6 is 4 half steps down from the root. With root 1 an octave higher on the 17th fret, we can identify 3 to 1 as a minor sixth inversion of 1 to 3, a major third interval. Subtracting the 4 half steps in the major third from 12, we get 8 half steps, which corresponds to a minor sixth interval. Remember, going up a major third is the same as going down a minor sixth. Simply put, going up 4 frets from 1 to 3 is equivalent to going down 8 frets from 1 to 3. Take a look at our interval chorder. We can use 4 as a reference point to locate a major third 1 fret below the root. Now, let's find the minor sixth inversion 3 to 1. Counting in fourths, 3 to 2 is a minor seventh interval of 10 half steps. Because a minor sixth interval has only 8 half steps, we must go down 2 frets from 2 to locate 1. The illustrations below provide a visual explanation of this logic. Let us now consider the inversion of the fourth and fifth intervals. Going up 5 frets from the root, we find 4. Going down by the same distance, we find 5. A perfect fifth is therefore an inversion of a perfect fourth interval. When we subtract the 5 half steps in a perfect fourth interval from 12, we get 7 half steps or frets in the perfect fifth interval 4 to 1. On the chorder, we can see 1 and 4 as adjacent fourths. To identify a 4 to 1 inversion on the A to D strings, we must count 5 half steps from 4 to flat 7, then add 2 half steps or ascend 2 frets for a total of 7 half steps, equal to a perfect fifth. We can also identify a 4-to-1 inversion on the A to G strings. 4 to flat 3 is a pitch distance of 10 half steps. To find a fifth with only 7 half steps, we must ascend 3 frets. With the strategies discussed in this lesson, you should be able to recognize intervals and their inversions using simple math rather than relying on memorized interval shapes. For a more in-depth look at intervals and their inversions, we recommend our book, Guitar Intervals Unleashed. The namesake app is available for download on the App Store and Google Play. In this context, the NANDI Chorder is an excellent practice tool for seeing the fretboard as intervals when you are not playing your guitar. There you have it, decoding interval inversions with the NANDI method.